Today we're going to make some servo code. Um, First thing we need to do is actually set our servo to a pin. So we've plugged into, let's say, pin 3, and we have a servo option here. Now if you click to connect to your servo, you will notice that you can actually move your servo by clicking and dragging the slider from 0 to 180 degrees. And you should see, if you've wired it up correctly, that it follows on the table. So we want it to move from 0 to 180 and follow through that loop process. So the first thing you might think to do is start your program, set an output, and place your servo, which should be down the bottom now, to position 0 degrees. We always need to wait, so let's wait a second, and then we're going to set the output to 180 degrees. The reason is if we don't wait, it should, or it will, just move instantly to each of those positions, quite erratically. So we're going to move to 0, wait a second, move to 180, and then create a loop back to the start. And I want you to run this program. Now what you should notice is that it moves very, very quickly. So it'll move instantly to 0 and instantly to 180. This can be a bit of a problem, like when you press a button and all of a sudden your door has slammed open and maybe torn off the hinges. So it's not really ideal for that situation. Or, say you were building a robotic arm and you wanted to control the movement of that arm, you would like to do that nice and slowly. You don't want to move instantly to a position, especially in instances like maybe a robot that needs to be more precise in manufacturing or engineering. So it needs to be moved nice and slowly. So in this case, what we do is we click the XY button at the top of our emulator, and it gives us a new symbol called let. This is a variable, so we now have variables that exist at the bottom. So what we can do instead here is we can say, at the very start, I want to let x equal, so there's the equal symbol, a number, and that number is going to be 0. Then the first thing we're going to do is output our servo, and instead of to a degree, now we're going to move it to x. So what's it, oops, sorry, I clicked the wrong one there, x. So what's it going to do? It's going to move to x, and x is 0, so it'll move to the 0 position. Then what we want to do is let x equal x plus 1. My mouse is being a bit dodgy today. Plus 1. So we start the code. X equals 0. Servo moves to x, so servo moves to 0. X is now going to equal x plus 1. So we've got 0 plus 1, it now equals 1. So we're going to wait just to make sure that this occurs and it moves nice and smoothly. We're going to wait 0.1 of a second, and then we are going to move our servo to that new X position, which will be 1. But what we want to do is eventually make sure that it reaches 180. So we actually need a decision. That decision is going to say, has X equaled to 180, which is our final position. So in the first loop, it's 0. We're turning servo to 0. We're doing 0 plus 1, so it now equals 1. We're waiting 0.1 of a second. Is it 180? Well, if it's not, which will be our two options of flow here, it's not 180, then we need to add 1 to x, wait 0.1 of a second, and check again. Well, now it's going to be 2, because x has started at 1, so now it's 2. It's going to loop again, then it's going to be 3, 4, 5, and keep stepping through those until it reaches 180. Once it reaches 180, what do we want it to do? We want it to work back the other way. So we can't just take a yes symbol and go back to here, because it'll instantly jump back to 0 and start again. So we'll slowly move to 180 and then snap back to 0. What I want you to try and do is repeat this in the opposite order and see if you can get it to work from 180 back to 0.